All right, this is what I was singing last week in class.
Mathematics. Mathematics. Man, that's exciting. Come on, that's a great one. Trying to make math more fun. Yeah, I want to download that one. That's good. What are you saying? Popular mathematics. Mathematics. I got the way it goes up. Oh, it's fantastic.
Yeah, so that's what I was trying to sing last week when I was like, popular quadratics. Quadratics. All right, anyway, so there's this possible rectangle we're talking about and all the different values. Oh, can I still manipulate this? Okay, good. Sorry about getting cut off in that last time. Oh, I guess I can't. Anyway, there's a limit to which, how skinny or how fat this thing can be. And there's a limit for x at 0. There's also going to be a limit for x when it gets to be about 60, because then, this edge is going to be 0, and that's whoa, sorry. Then the area is going to be 0 also when we start to get a value of x close to 60. So you go back to the calculator and you see this graph, and yeah, so at 0, and it appears to get about, well, maybe about 60, because this 62.01 is the edge of the window. Yeah, so it looks like at 0 and 60 there's going to be kind of a limit, like we can't go past that. And then the range, well, the range is a lot more difficult. Like, I got to figure out what's the height of this maximum. Well, you know what? I got this fancy calculator. It can tell me this. Maximum between here and here. You still singing that song? Popular quadratics. All right, so it's 900 is the biggest area I can get, and happens to be when x is 60, or sorry, when x is 30. You may have known that. Let me fill that in. Yeah, so the x values can range from 0 to 60, they can domain from 0 to 60, and the range of possible areas. Yeah, you could get an area of 0 if you had an x value of 0 or 60, and then the highest we ever saw the range to be was 900. That's the biggest area you could ever get. What should the dimensions be to enclose the maximum area? Well, we just figured this out, that the maximum area happened at that vertex where x was 30. So if x is 30, I'll say it this way. If x is 30, think about this. If x is 30, what's this other dimension going to be? Well, it's going to be 60 minus 30, which is 30. And if you think about that for another second, you realize that, yeah, of course, that's the area that's going to be 900, as long as it's 30 by 30. And if you've done enough of these problems, you realize that this always happens when we're talking about a square. Square is going to maximize the area and minimize the perimeter at the same time. Okay, what would be the dimensions if the farmer also had to enclose exactly 704 square yards of area? Okay, so we want to basically figure out where's the value of, where is x such that the value of f of x is going to be 704. A couple ways to do that. We could make a table, and we could look through the table until we found the value of 704. That would be Control T. You get this table. So this is telling you that if you have a 1 by 59 rectangle, it's going to be 59 area. If you had a 2 by, what would that be? 2 by 58, it's going to be 116, and on upwards. We know this is going to eventually go to 30, 900, right? Now, would we ever see a 704 in here? I must have passed one, right? Oh yeah, there's a 704. A 704 happens at 16, and as we keep going past 900, it's going to come down again, right, in the parabola, and we get 704. So what happens at 44 and 16? Was it 16? Let me go back here. Yeah, so 16 and 44, and think about this. If x is 16, what's the other dimension? It would be 16 for this one, and oh, guess what? 44. So if you put 44 here, this would be 16. So that describes the same shape, rectangular pen here. So it's going to be 44 by 16. If you didn't want to do that in a table, another way you could do that is you could graph, we did this in the last problem, we could graph a new function. We could graph the horizontal line that is 704, and we could figure out where that crosses the axis, or crosses the parabola. And just by doing intersection, we could do intersection and go from here to here. There's the 16. If you really wanted to, if you weren't sure where that other one was going to be, I'm guessing 44. Yeah, it's going to happen at 44. So there's those two places. Okay. So anyway you slice it, it's going to be 16 by 44. I thought of another way to do that. We could actually do that in a calculator page. If I went add a calculator page, I could basically just solve where is f of x equal to 704. Solve that for x, and it's going to be 16 to 44. That's kind of nice too. Okay. Cell phone manufacturers finds the profit they earn is a function of the price they decide to charge for the cell phone, modeled by the function of this. So guess what? Let's put this in the calculator because these are pretty yucky numbers. And of course, this is calculator day on the video. So during a test, you ever faced with making a new graph, doing the next problem? You could go and make a new document for every single problem. That's fine. If that bothers you and you know you're done with this and you want a faster way to like get on with your life and get on to the next problem, you could just go in here and you could just delete the functions that are already here. You can actually just uncheck that. So I'm just going to show you another way to do things actually. Is that gone now? Yeah. And so let's just get rid of this and let's just, ooh, I went too far. Escape. You can always escape and get out of stuff. All right, so what do I want here? I want negative 30, and you really have to use X for all these, even though it's, they're using P and R here for revenue and price to give some meaning to their variables, which is always good, but the calculator doesn't care. The calculator just wants to do X. Okay. Well, if I do that, the problem is if I put that in there, yeah, it's graphed it, but the window I'm in for that last problem has nothing to do with the window for this problem. You can always find something on the function if you go window zoom fit. That'll get me something. Again, it doesn't always give me the vertex, which I kind of wish I had. So let me zoom out in the direction of where I think the vertex is, like over here, until I eventually get a vertex. Okay, there's a vertex over there. Let's go one more time. Then let me box that in. Menu, zoom, box. And let's get the fun stuff. Make sure I go from that. Let's go from that corner to this corner. So I'm grabbing, make sure my window includes the vertices and, the vertex and the intercepts, and we'll go from there. Now it has some points graphed here. That could be a remnant from the last problem I was doing. I really don't think that's very helpful for anything. It doesn't bother me that it's there. It's kind of in my way, but it's not going to mess me up, I guess. Too bad. All right, sketch a graph, making sure to include the important points and intercept and vertex. Well, you know what? Let's just do this right now. Let's show the intercepts and the vertex. So the intercepts I can get with menu analyze 0. Let's do one over here. And let's do one over here. Menu analyze 0 between here and here. Okay. So there's one that seems to be one at 500. There seems to be one at 0. Yeah, if they charge 0 for the cell phone, they're going to make 0 in profits. I guess that makes sense. If they charge $500 for the cell phone, they're going to make 0 in profits, probably because they're not going to sell any. So that's probably the contextual meaning of that. They also wanted vertex, so let's do this. Analyze maximum in this case between here and here. So there's a vertex. Oh, here's one of these little e to the 6 things, or this e plus 6. What that means is this little number up here, 1.87. Remember, this is a cell phone company. We're talking about revenue of the entire company, like a company like Apple or Samsung. Like, this is a huge number. This little e, just like I talked about this in class, when you see that in a calculator page, little e at the end of the little tiny, like small capital E means times 10 to the power of whatever number's next. And it'll either be a positive or a negative number. For positive numbers, this is scientific notation. This denotes 1.87 times 10 to the 6th power. This basically means $1.87 million. If it was times e to the negative 6, it would be 1.87 millionth of a dollar. So you got to really pay attention to this because it makes a huge difference. So that's our maximum. So sorry, what was the question? Sketch a graph. Okay, I want to cheat. I'm just going to drop it in there. And by cheating, I mean I'm actually going to just screenshot this. So that's fine. Yours can look, of course, like you drew it. That's fine. But whoops, I'm going to show you the parts I care about. Okay, that's a little too big for this. I'm going to shrink that down. Way easier on a computer than it is in real life with a pencil. Okay. Give the plausible domain and range in this situation. Well, we just kind of talked about this, that the domain is going to be, we really don't want to consider values before this 0, and it seems like it goes up to 500 before it hits 0 again. So that's that. Range appears to be going from 0, because again, we don't want to consider negative dollars, even though we know this function actually goes below the axis. And how high does it get? It gets to be something like 1.87 to the 6th power. So I'm going to write that as 1. It's kind of strange with that in there, but you can tell it's $1.87 million like that. What price should they charge to maximize profits? Well, I can tell right now. It's going to be $250. $250 is the place where I hit the vertex. So by doing all that stuff and just graphing what they asked for here, I can answer the next couple questions already. Within what price range should they charge if they want to have profits of at least $1.5 million? Okay. So if you look at some point, there's a height here where we reach over $1.5 million. The maximum here is 1.87. But there could be other restrictions in this scenario, like maybe there's a certain market niche they want to try to target, or there's some other restrictions on production. Anyway, so they want to know, well, what's our wiggle room if all we want to make sure is we make more than $1.5 million? Let's try this. Let's do a 1.5 million horizontal line and see what we're talking about. So we're talking about between this point and this point, what's this range of x values where they're going to make at least 1.5 million or more. So really what I want to know is, where are these intersection points? Sorry, trying to talk fast here so I don't run out of time like last time. So there's one at 138, and I could get that other one just algebraically once I know one. Anyway, because they're symmetrical. But anyway, between 138 and 362. All right, so they know that in that zone, they will have profits that go, they start to reach 1.5 million after you get to 138 and above. But after 362, they start to sell so few because it's such an overpriced, crazy price, they're going to make less than that. So, all right, last one, quadratic regression. We actually did this one in class, but we only did it once, and I thought maybe you want to see this on video to have something to refer to. Okay, so the first thing is, get this stuff in a spreadsheet. So, like me at this point in the test, you probably have too much junk. We need a new list in spreadsheet. So try Control-Doc, add list in spreadsheet. You have to name these two columns. You have to name the columns in terms of something you're going to refer to later, like time. How about hours? And how about concentration? It really doesn't matter as long as you can remember later what they are. And then just enter all the data. Okay, 70.4. All right, I got it all. So you get it all in there in a list and spreadsheet page. And then we want to add what's called data and statistics. This is the way I did it. I think the sub did it with you a different way. I kind of like this better. This is the way we do it in AP Stats. Add data and statistics. It just throws random numbers in random places until you say, no, I want hours down here. That's my X. And I want concentration up here. That's my Y. And I can kind of see where these numbers are going to look like, what this data is going to look like on a parabola. And if I go menu, analyze, regression, and I guess that's kind of hinted at you because it's in the stem of the problem. Show quadratic, it puts this on here. And it gives you this nice function. And this is what I want to enter. Oh, can I enter this nicely? And it saved this somewhere. Anyway, I'm going to enter this as my equation that it wants for the question. There it is. I know I can find it. If I go to calculator page and go var, it gives me all the stuff that the calculator is storing in memory for this document. And if I ask the thing to go is this actually for regression equation, and I want it to show me how that operates on X in general, it'll give me that thing, which is really nice. So you can see more decimals that way, and it's not kind of jumbled up in the middle of the graph. Yeah, so there's the equation in standard form. Standard form, I guess, is the only one it's going to give you on the calculator. So don't try to impress me and do a different form. Just give me standard. Use this equation to find when the concentration will drop below 20. All right, so basically I'm trying to find out when is this 20, or when is f of x equal to 20. And if I'm letting you do the solve command, all you got to do is solve the stat reg equation of x when it equals 20, 20 for x, that's a comma x, and they'll tell me. It's going to happen in two places. Or graph this on a graph page. Go to Control-Doc, graph. I want this to be the regression equation of x, and there it is. Oh, that's a horrible picture. Let's zoom out. Zoom out. So the vertex is way up here in the stratosphere, so at some point, oh my gosh, look how far it is up there. I'm going to zoom box this so it looks better. Get around everything interesting. Oh, let's do that again. From like here down to there. Okay, that's pretty close to what I want. If I do zoom fit now, it'll probably show me what I want. Okay. Maybe shrink this up just a little bit. Okay. So if I get that equation where I want it, the question was, oh, I lost it. I'm not having time. When are we at 20 milligrams per liter? So I could graph another one where it's 20. Sorry, just graph a horizontal line at 20 and see where those intersect. That's one way to do it. So I'm running out of time. Or put in the calculator page, solve this for when it equals 20. like I've done here. All right. And of course, we're not surprised that that's 2 different times. Okay, I'm out of time. Remember to hit the var button to get those stat reg equations. All right, see you in class.